We're on topic 13, but before we go to page 61, which is the page where topic 13 starts, I'm going to give a little introduction to factoring. And first of all, we're going to define a composite number. So a composite number is a number that can be written as the product of two positive integers, other than 1 and the number itself. For example, 14 is a composite number because it can be written as 7 times 2. And 7 and 2 are called factors of 14. We take 16, for example. 16 is a composite number because it can be written as the product of 8 times 2, or the product of 4 times 4. So some of the factors of 16 are 2, 4, and 8. A composite expression is similar in that it can be written as the product of two or more expressions. If we take the expression, the trinomial x squared plus 3x plus 2, we can write it as x plus 1 times x plus 2. In other words, this expression is equivalent to this. How do we get that? We use what's called the FOIL method. So the first times the first, plus x times plus x, gives us plus x squared. The last term is plus 1 times plus 2. That's right here. And in the FOIL method, we have the outer and the inner. So the first times the first is the x squared term, right here. The last is the plus 2. And now we use this to combine the outer and the inner. So the outer is plus 2 times x, and the inner is plus 1 times x. So we're adding 2x and 3x. 2x and 1x, sorry, and we're getting 3x. So the combination of the outer and the inner gives us this middle term. So here we say x plus 1 and x plus 2 are factors of x squared plus 3x plus 2. In general, a number is a factor of another number if the first number can divide the second without a remainder. So 12 divided by 4 gives me 3. So we say 4 is a factor of 12. Because when we divide 12 by 4, we get 3, and there's nothing left. There's no remainder here. It's an exact division. Similarly, we could multiply 12 by 3 and get 4. So 3 is also a factor of 12. Now we're talking about an expression. Similarly, an expression is a factor of another expression if the first can divide the second without a remainder. So here we're taking x plus 1, x plus 2, and dividing it by x plus 2, and the x plus 2 cancels, and we're left with x plus 1, no remainder. Now, we could have also written, instead of put x plus 2 here, we could have put x plus 1, and then we would have gotten the x plus 1 cancels, and we would have x plus 2. So the two factors of this expression are both x plus 1 and x plus 2. Right here, x plus 1 and x plus 2 are factors. And the reason is when we divide these into the original expression, there's no remainder. So factoring is a process by which the factors of a composite number or a composite expression are determined. And the number of the expression is written as a product of these factors. For example, the number 15 can be factored into 1 times 15, the asterisk here means times, 3 times 5 gives you 15. Minus 1 times minus 15 gives you plus 15. Minus 3 times minus 5 give you plus 15. So the numbers, the 4 negatives and the 4 positives of these numbers, minus 15, minus 5, minus 3, minus 1, 1, 3, 5, and 15 are all factors of 15 because they divide 15 without a remainder. So that's very, very important. And factoring is a process in algebra which is used to simplify expressions, fractions, and solve equations. If you see, for example, we take the number 24, you can see that we can divide 2 into it, 3 goes into it with a remainder 8, 4 goes into 24 times 6, and so here are 24 times 1 gives you 24, 2 times 12, 3 times 8, and 4 times 6. We can take the negatives of these also. Minus 24 times minus 1, minus 2 times minus 12, minus 3 times minus 8, and minus 4 times minus 6. So starting on page 61, there are different parts of this page that we're going to examine. We're going to look at the greatest common factor. We're going to look at trinomials. Trinomials have 3 terms where we have descending powers of x. This is x squared. This is x to the power 1, even though we don't write it, plus abx to the 0. So there's 1, 2, 3 terms. And here in this first case, the coefficient of x squared is 1. That means the number in front of the x squared. It's implied that there's a number 1 here. We're also going to look at trinomials where the coefficient of x squared does not equal 1. This little equal sign with a line through it means does not equal. And so here we have a times c times x squared. So that's one term, plus AD plus BCX plus BD. So this is 1, 2, 3 terms. It's a trinomial. And we're going to examine that and see how we can factor it. Some special factorizations are perfect square trinomials. So this has 1, 2, 3 terms. Can be simplified as x plus y squared. This can be simplified as x minus y squared. We're going to look at the difference of squares right here, and we're going to look at the difference and sum of cubes. Here is the difference of cubes. This is a cube and that's a cube. This is the sum of cubes. And we're going to look at how we can look at a trinomial of the form ax squared plus bx plus c and determine if it can be factored using integers. So this term can be factored over integers means that integers are the solution to the trinomial. So let's go to the greatest common factor. Here, if we look at this term ax plus ab, we can see that the letter A is common to both the first term and the second term. So we can take out the letter A, and then we can see that A times x gives us ax, which is the first term, and A times plus B gives us plus ab right here. So that's the generic form, and we're going to look at some very specific examples. If we take 3x plus 6, we can write this as 3 times x plus 3 times 2, and we can factor out the number 3. The number 3 appears here, and the number 3 appears here, so we factor it out. 3 times x gives us 3x, and 3 times plus 2 gives us plus 6. You take the next equation, 26x plus 91, we can factor out the 13 from both terms. So we could 13 times 2x gives us 26x. 13 times 7 gives us 91. Now 13 appears here, 13 appears here, so I can take it out and then put a brackets, and by the distributive rule 13 times 2x gives me 26x. 13 times plus 7 gives me plus 91. If you take the expression 12x minus 36, we could certainly factor out the factor 2 from this and say 2 times 6x gives me 12x. 2 times minus 18 gives me minus 36. And slight error here, this should read minus 36 here. So let's just correct that. So 2 times 6x gives us 12x. 2 times minus 18 gives us minus 36, which is the original expression. But 2 would not be the greatest common factor. 12 would be the greatest. So you could see that I could write this as 12 times x, and instead of 36 I could write 12 times 3. 12 is common to both of these, and 12 times x gives me the 12x, and 12 times minus 3 gives me the minus 36. So 12 is the greatest common factor. If we took out 2, we would not be taking out the greatest common factor. So let's look at trinomials, and we're going to look at trinomials with a coefficient of x squared is 1, so implied here is a 1. Now what we're going to do is we can factor this and get this. We're going to start with the right-hand expression and go to the one on the left, this one here. So we're going to set this up, put this right over here, it's right here, and we're going to use the FOIL method, which we've previously described. And in this particular case, the F stands for the first term in the first bracket and the first term in the second bracket. So x times x gives me x squared. Now I'm going to deal with O, which is the outside one. So the outside term here, including its sign, is multiplied by this outside term here. So plus x, and this is plus, so we get plus bx. That's the outer term. And then the inner term is this one right over here, plus a times x, plus a times x. That's the inner one on these expressions. Okay, so I get plus ax. And then the last times the last is plus a times plus b, and I got plus ab. So using the first times the first, the way to, let's go over it again. First times first gives me x squared. The outer one is plus b times x. I get that. The inner one is plus a times x, gives me that. And the last plus b plus a times plus b gives me plus ab. So first, outer, inner, last. Now if you look at the second and third terms here, second and third, what's common to them? The letter x. So I'm going to factor out the letter x, and by distributive rule, x times b gives me bx. It doesn't matter whether I write this as xb or bx. I mean, usually we write it alphabetically. X times plus a here gives me plus ax, so I get this. Now the last term is ab. So all I've done is take this, I've left the first term the same, there it is. I've left the last term the same, there it is. And I factored out x from the second and the third term, so I get xb b plus a. Now I've just rearranged this here. There's no difference between this expression here and this one, except that I put the x, I've rewritten, instead of b plus a, I've written a plus b, and then I put the x as a second term. So this expression and that one is identical, and this now is equal to this term over here. So this one and this one are the same. So this is a trinomial, and we can look at this example here. X squared plus 4 plus 3x plus 4 times 3, and we can say that the a is the 4 and the b is the 3. And if we look over here, x plus a, which is 4, times x plus 3. And here we have a plus b, which is this middle term right over there. So what we're saying is that this can also be written like this. Now we could have added these 4 plus 3 and gotten 7x, so that's acceptable too. Now looks at trinomials where the coefficient does not equal 1. This little equal sign with a line through it means does not equal. And there's nothing here to memorize because it looks very, very complicated, but it's not if you really break it down. So what we're going to do again is start from the right side and work towards the left. So if we take ax times cx, which is the first term, times the first, we get ax times cx, acx squared. So that's this one right here. If we take the outer term plus d times plus ax, I get a dx. The order of which I write the letters doesn't matter. So this is the outer term. Ax times d gives us a dx. The inner one is these two together. So plus b times cx gives me the next term, which is bcx. And the last times the last, plus d times plus b times plus d, plus b times plus d gives me plus bd. So all I'm doing is taking this and coming out with the FOIL expression. Now, I'm not going to change this, but the second and third term, I can factor out x from the second and third, which are really the outer and inner. So factoring out x from the outer and inner terms gives me the first term stays the same and the last term stays the same. So I'm factoring out x from the second and third term, or the outer and the inner. So I get AD plus BC. So now what I've shown is that starting with this, which is this expression right here, gives me this expression right here, which is right over there. Now, to put some numbers here, let's say I make A equal to 4 and C equal to 2, and then I make B equal to 3 and D equal to 5. So I'm giving just randomly choosing some numbers here. In this case, I make it easy, make them positive whole numbers. So AC is 4 times 2, x squared, plus, now here I'm going to write A times D, so A times D is 4 times 5, plus BC, BC is 3 times 2x. We're talking about this term right here, replacing everything here, plus the last term BD, which is B 3 times 5, and there's BD here. So this expression here with all the numbers in it is this one right here. And then the simplified expression of this is right here. So A is 4, B is 3, C is 2, and D is 5. Now, you don't memorize this. We will be doing more complicated examples and showing you how to factor those later on. So let's look at special factorizations, the next topic on page 61. There's 3 cases: perfect square trinomials. And right here we see x squared plus 2xy plus y squared can be really written as x plus y squared, which is equal to x plus y times itself. X plus y squared is x plus y times itself. And if you combine the inner xy and the outer xy, we get the plus 2xy. If you got to include the signs, plus xy plus xy gives us plus 2xy. Now, if you take x minus y squared, this means x minus y times x minus y. First times the first gives me the x squared. I combine the inner and the outer. I get minus 2xy. And plus y times, minus y times minus y gives me plus y squared. So here again, first times first gives me x squared. Last times last, including the sign, gives me plus y squared. And I can take this and multiply it by 2, product of these two, including their sign, and get the middle term. Same thing over here. Let's take a look at some examples. 81x to the 4th plus 72x squared plus 16 is really factorable as 9x squared plus 4 squared, because I'm multiplying this by itself. So if you multiply the first times the first, I get 81x to the 4th. I multiply plus 4 times plus 4, I get plus 16. I multiply plus 4 9x squared and plus 4 and add it to plus 4 9x squared. I got 36x squared, and 36x squared gives me 72x squared. So twice the inner or outer terms is plus 2 times 4 times 9, which is plus 72x squared. Because the inner and outer terms are the same, so I can just multiply either one by 2. In this case, if I take 9a squared minus 30ab squared plus 25b to the 4th, this is 3a minus 5b squared, brackets, all squared. So I'm multiplying 3a minus 5b squared by itself. Now, the first times the first gives me the 9a squared. Minus 5b squared times minus 5b squared gives me plus 25b to the 4th. The inner and outer terms are minus 15ab squared. If I multiply that by 2, I get minus 30ab squared. So you can combine the inner and the outer, or you can say twice the inner or outer terms, whichever you prefer. But always watch out for the signs here. Make sure you have the signs right. Now, the difference in squares, the inner and outer terms always sum to 0. Because this is the same as this, the inner term is plus xy, and the outer term is minus xy. So, plus xy and minus xy. So, the inner and outer terms sum to 0. The first times the first gives you the x squared, plus y times minus y gives you minus y squared. So there's only 2 terms here, and that's because the inner and outer always sum to 0. If we take this and try to factor it, the first times the first gives me the 4a to the 4th. The plus b times the minus b gives me the minus b squared. The outer is minus 2a squared b, and the inner is plus 2a squared b. Notice this has to be the same as this. This has to be the same as that. The only difference here is the signs. 49x to the 6 minus 9x to the 8th. We can write that as 7x cubed plus 3x to the 4th. 7x cubed minus 3x to the 4th. The first times the first gives us 49x to the 6 because we add the 3 plus the 3. 49x to the 6. Plus 3x4 times minus 3x4 gives us minus 9x to the 8th. We add the 4 plus the 4 power, and that's how we get the 8. Okay, the inner term is canceled by the outer term in here. In other words, plus 21 x to the 7th is canceled by minus 21 x to the 7th. So if we factor this here, we get 9a squared plus b squared and 9a squared minus b squared. So the first times the first gives us 81a to the 4th. The inner and the outer cancel. Plus b squared minus b squared gives us minus b to the 4th. Now you would think normally that you just end the problem right here. But you see, this is factorable again, and this is what we always have to look at. This, in the second bracket, is factorable to 3a plus b and 3a minus b, because 3a times 3a gives us 9a squared, and plus b times minus b gives us minus b squared. The inner plus 3ab and the outer minus 3ab cancel. So you can see that you should always look and see whether something is still factorable. So there's essentially a double factor here. You factor this once, and then you can factor this again a second time. The difference and sum of cubes. So the difference here is because of the minus, the sum is plus, and this is written as x minus y times this. Now we're going to take this difference for the first equation and we're going to expand it. So we're going to take x times this whole bracket, which is this right here, and then we're going to subtract y, which is right here, and we're going to multiply it by the second bracket. So let me repeat. X times the contents of the second bracket, which is this, then the minus, which gives me this minus, and then y times the contents of the second bracket. So I've got that right here. Now when I multiply this out, x times x squared gives me x cubed. X times plus xy gives me plus x squared y. And x times plus y gives me xy squared. These two terms are different because one is the x is squared and here the y squared. So we get 1, 2, 3 terms. I'll explain why there's a red line and green line. Now I multiply minus y times x squared. I get minus y times x squared, which is this term here, just that I've written it alphabetically. The second one is minus y times plus xy, which gives me minus xy squared. And the final term, minus y times plus y squared, gives me y cubed. So this term, the two reds sum to 0, and the two greens sum to 0. So all I'm left with is x cubed minus y cubed, which is this expression here. So I've shown how this simplifies, to this. Now, let's look at a few examples here of a cubed minus 8b cubed. This can be written as a cubed minus 2b cubed. So 2 2 times 2 to the power 3 is 8. So instead of writing 8b cubed, I'm going to write 2b cubed. The cube applies, gives me 2 cubed, and the cubic applied to the b gives me b cubed. Now I can write this in this general form here, a minus 2b. So I take a minus 2b, and then the square of the first term. The product of 2b and a, but now I'm going to reverse the sign to plus 2ab. That's not actually how you get it. We're just saying that this is simplified in terms of this here. So you can see that this minus is the same as this minus, but if this is minus, then this becomes plus this term here, and we're really taking the product of this term and that term, and the product of a and 2b is 2ab. And then finally, the last term is this term squared, which is 4b squared. So similarly, if we take 27x to the 6 plus 64y to the 9th, 3 cubed is 27, and x squared times the power 3 out here, 2 times 3. We multiply these two together, we get the x to the 6. So 3 to the power 3 gives us 27. This to the power 3 gives us x to the 6, plus 64 is 4 to the power 3 when we put this in brackets. And the 3 here times the 3 here gives me y to the 9th. So now I write this individually, 3x squared plus 4y, 3x squared plus 4y cubed, this term plus this term. I square the first term, get 9x to the 4th, change the sign, minus, multiply these two together to get this term, and then plus 4y cubed squared is plus 16y to the 6th. So let's go over this again. We break this down into two expressions. One is x minus y. You'll notice there's no cubed here, no cubed here. We square this first term, we get this. We multiply these two together, and then we change the sign to get this one. And then we square the last term plus y squared. So the only negative term is right here. When this is positive, this one is positive here. This minus changed to a positive, and this plus changes to a minus. Now you have to practice that a little bit, and we will. This is probably a little tricky to remember, but when you practice a lot, you remember it. Okay, what are the conditions for factoring, for getting integers as factors? There are really 4 different cases that we should examine, and we have a trinomial can be factored over integers, which essentially means that we get integers we can factor with only integer solutions, only if the b squared minus 4ac equals 0, 1, 4, 9, 16. So you'll notice the 1, 4, 9, 16 are perfect squares. This is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared. We could have continued 25, which is 5 squared, and 36, which is 6 squared. Let's take some examples. Let's take this case here. A is the coefficient 3 right here. B is the coefficient in front of the x, and C is this number here. And if we apply b squared minus 4ac, we get b squared 16 minus 4ac minus 4 times 3 times 1. 16 minus 12 equals 4. 4 is a perfect square. It's 2 squared. So we get integers as solutions. This can be factored as this. You can see 3x times x gives me 3x squared. Combination of the outer is plus 3x plus the inner plus x gives me plus 4x. And the last times the last gives me plus 1. So when we get a perfect square, we know that we are going to get integer solutions. So when this number, b squared minus 4ac, is a perfect square number, we are going to get integer solutions. Case 2 is a case like here, 3x plus 9x squared plus 12x plus 4. And in this case, b squared would be 12 squared minus 4ac, 4a, and c. So when we multiply this out, 4 times 9 is 36. 36 times 4 is 144 minus 144. I get 0. This factored expression is a perfect square. In other words, both terms inside the brackets are identical. So if b squared minus 4ac is equal to 0, still get the integer solutions, but whatever the integer solutions are, or whatever the integers are, they're the same for the first bracket and for the second bracket. Here, what I have here in this bracket is not the same as that because this doesn't equal 0. If it equals 0, I get integer solutions, but what's in one bracket has to be in the same as in another. This is a perfect square. So, here, case 3, b squared minus 4ac is 3 squared, because b is 3, minus 4, a is 1, and c is 1. So ac, 4 times 1, 1. 9 minus 4 is 5. This factored solution, whatever it is, will not contain integers because it's not a perfect square and it's not 0. So the factored solution will not contain integers. It's factorable, but you can't use integers. In this case, we get b squared is 3 squared minus 4ac. There's a, there's c, 1 times 5. So 9 minus 20 is minus 11. Here the result is negative. This expression cannot be factored, so there's no factorable solution here to this expression. Well, this completes our review of page 61.